Right now, as you watch this video, someone somewhere is withdrawing cash from an ATM. A traveler is checking the status of a flight, and a hospital is pulling up patient medical history. And of course, various banks are processing millions of transactions simultaneously in the background. All of that is being handled by an operating system you have probably never heard of. It is called ZOS. It does not run on your laptop, it does not run in the cloud, it runs on a machine called mainframe. And it quietly powers the most critical infrastructure on the planet. Apart from that, you will be surprised to know that 95% of the world's ATM transactions, 87% of all credit card transactions, over 30 billion transactions processed every single day are processed or supported by ZOS. So, ladies and gentlemen, welcome back to today's session on what is ZOS. And in this session, we are going to answer one simple question, that is, what exactly is ZOS? And why does the world still depend on it in 2026? By the end of this video, you will understand how it works, what make it different from every other operating system that we have today. So let's start from the beginning. So first of all, what is an operating system? So in layman term, an operating system is a software that sits between the hardware and everything else. It manages memory, run programs, control storage, and make sure everything works together. And I'm sure you might have come across with Windows, Linux, and you might have seen Mac OS. And these are all operating system and they have been designed for broadly the same kind of workload, that is one user or a handful of user doing general purpose computing on commodity hardware. Now the next important question that would be there in your mind is that how come ZOS is different from other operating system, for example Windows, Linux, or any other operating system that we have in the market? Well, the answer is pretty simple. The ZOS operating system was designed for IBM Z series of mainframe computers. And it was not designed for general purpose computing. It was designed for a very specific use case, that is, running high volume of transactions simultaneously, reliably, with zero downtime. Now, let me give you a sense of what that means in practice. A single commodity Linux server might handle a few thousand transactions per second, or maybe tens of thousands if it is well tuned. A properly configured cloud cluster can push that even further. But a single IBM Z mainframe running ZOS operating system can process over 1 million transactions per second on its own. That means one machine, 1 million transactions per second. And while it's doing that, it is also running bad jobs in the background, managing terabytes of data, enforcing security policies, and producing audit logs for everything that happens. This is what ZOS is built for. Now, you might have heard people saying that mainframes are outdated and sooner or later they will be replaced by cloud agnostic system. So in that situation, I want you to remember that number, that is 1 million transactions per second from a single machine with 5 nines of availability. That means less than 5 minutes of downtime per year. Now, the cloud technology is extraordinary and there is no question about that. But there is a specific reason why the world's biggest bank have not moved their core banking application to any other platform. It is not basically a nostalgia or a stubbornness. It is because nothing else does what ZOS does and at what scale it does actually. Now, in order to understand the ZOS, you need to understand the history, and it is genuinely a remarkable story. Back in 1964, IBM is the most powerful technology company in the world, and they were about to make a bet that will define computing for the next 60 years. They announced the System 360, a family of computers designed to cover everything from small business to scientific research with a single compatible architecture. And this was a revolutionary step because before System 360, every computer was essentially on its own. Software written for one machine did not run on other, and IBM has changed that. And with that, it changed the industry. Now, in order to run System 360, IBM built OS 360, the operating system. And in that original system, you can already see the DNA of what would eventually become ZOS. The concept of job, that is basically a unit of work you submit to the system, defined with instructions, and let the machine execute. The concept of batch processing, that is basically a work that does not need an immediate response. It generally run over the night and produce a result in the morning. And the concept of JCL, which is job control language. So the language that you generally use to define these jobs. So these ideas are actually born in 1964, and these concepts are still used in today's world without too much change in their essence. Through the 1970s, IBM kept evolving the platform. MVS, that is multiple virtual storage, arrived in 1974. It introduced virtual memory, letting programs behave as if they have more memory than physically existed. This breakthrough made ZOS multitasking possible. The 1980 brought further expansion, massively increasing how much memory the system could work with. And then comes something that surprised people. In 1990, IBM added Unix compatibility to the platform. That's right. ZOS can run Unix applications natively. It has a full Unix environment built in. So when industry was debating whether Unix or Windows would win, the mainframe quietly added support for both. In 1995 came OS 390, a major refresh, and then in 2001 IBM released ZOS, named after the IBM Z hardware it runs on. ZOS brought 64-bit addressing, improved scalability, and a tighter connections between the software and the hardware beneath it. Today, ZOS keep receiving updates. IBM has added container support, cloud integration, AI workload capabilities. This platform is not standing still. The one thing that I would like to highlight here is, or a key takeaway from this history is that every major bank which is running ZOS today has been building on this platform since the 1970s or 80s. Their core business logic, that is the rules of how actually account works, how transactions are checked, how risk is managed, is embedded in systems that have been running and improving for last 40 odd years. And this is not legacy debt. This is 50 years of battle tested engineering. And ZOS is what make it run. Now let's get into how ZOS actually work. And you don't need a computer science degree to follow this. But I want to give you a real understanding of the architecture because it actually explains everything. So ZOS is built around two types of work, that is batch processing and online transaction processing. And let them take one by one. So batch processing is the work that happen in the background, usually overnight. Think about what a bank need to do every night. Calculate interest on millions of accounts, generate statement, reconcile transactions, run fraud detection across the daily activities. None of that is needed to happen in real time. So it's get bundled into jobs, defined using JCL, submitted to the system, queued, executed, and reported on. The component that manage this is called JAS, that is the Job Entry Subsystem. So JAS is the traffic controller for batch work. It receives jobs, schedule them, capture their output so operator can review what happened. Online transaction processing is completely different. When you tap your card at a shop, a transaction fires in millisecond, it hits the bank system, and ZOS handle it through a component called CICS, that is the Customer Information Control System. It actually manages thousands of requests simultaneously in real time. It look up the account in DB2, which is basically an IBM relational database. It checks the account, validate the transaction, update the record, and return a response. And remember, everything happens under a second. And here's what makes ZOS extraordinary. Both of these things happen at the same time. While your bank is running overnight batch jobs for millions of accounts, it is simultaneously handling thousands of real time card transactions from customers around the world on the same machine, on the same operating system, without either workload slowing the other down. So, this is possible because of something called Workload Manager or WLM. So, Workload Manager is a brain of COS resource allocation. It watches everything happens on the system, CPU, memory, storage, and allocate resources based on a defined priorities. Mission critical real time transactions get resources first. Background batch jobs use whatever is left, and Workload Manager rebalance this thousands of times per second automatically. Underneath all of this is ZOS memory model. Every program running on ZOS lives in its own address space. It is basically an isolated region of virtual memory, and program cannot access each other memory. They cannot interface with each other during the execution. And this isolation is fundamental. If one application has a bug, even a serious one, it cannot bring down the rest of the system. The operating system contains the failure, everything else keep running. This is one of the reasons why ZOS achieve 5 nines of availability. Not because nothing ever goes wrong, but because when something goes wrong, the system is designed to contain it, recover, and carry on with the work. And beneath all of that is the hardware itself. The IBM Z processor is not a standard chip like the one that you find in your laptop. It is a custom designed with a dedicated circuit for cryptography, data compression, and transaction processing. The hardware and the operating system are not separate products bolted together. They are actually co-designed. IBM engineers the chip and the operating system together as a single system. The co-design is another reason why ZOS performs the way it does. You cannot replicate these performance characteristics just by running it on different hardware. The hardware is a part of what makes it work. Now let's talk about the key component of ZOS. So ZOS is not a single piece of software, it is basically an ecosystem of components and each responsible for a specific function. Let's walk through the most important ones, the ones you actually encounter if you work in a mainframe environment. So very first component is JAS, that is Job Entry Subsystem. It is this system what makes batch processing possible on ZOS. When a programmer submit a job written in JCL, JAS actually receive it, assign a job number, queue it, and schedule it for execution. And when the job finish, JAS capture all the output, logs, the reports, and the error message. In mainframe environment, this output is called sysout. And programmers and operator generally refer sysout for the error message or the stats that have been generated by the program or the job. There are two different versions of JAS, that is JAS 2 and JAS 3. So JAS 2 is by far the most common in modern environments. Now let's talk about our next component, that is RACF, that is Resource Access Control Facility. Security on ZOS is handled by RACF, and when I say security, I mean everything. Who can log in, which data they can read or write, which program they can run, which command they can issue. Every access request on ZOS goes through RACF. It checks against its database of users, groups, and permission. And based on rules, either it can allow or deny access to the user. And remember, it logs everything. This level of security is one of the reasons why ZOS is trusted with the world's most sensitive financial and personal data. Now, the next component is DFSMS, that is Data Facility Storage Management Subsystem. So as you all know that mainframe is known for its processing capability or processing power. It just processes billions of transactions every day, every second. Now data storage is something which is a complex problem. You have hot data that needs to be accessed in milliseconds. You have warm data that needs to be available but does not need to be on the fastest storage. And you have cold data or archive that you rarely access but must be available as and when it is required. So DFSMS manage all of this automatically. It moves data between storage tiers based on how often it is accessed, handle backup and recovery, and ensure the right data is on the right storage at the right time. Without DFSMS, managing the petabytes of data flow through a mainframe environment would require army of storage administrator. And with this component, most of it is automatic. Now let's talk about our next component, that is CICS, that is Customer Information Control System. And we have already mentioned CICS in the context of real-time transactions, but it deserves its own momentum here. CICS is a middleware that makes online transaction processing possible on ZOS. It manages the full life cycle of a transaction, that is receiving request, outlining them to a write program, managing access to shared data, and returning response. It handles thousands of concurrent transactions and ensure that partial failure did not corrupt the data. If DB2 is the database that stores the data, then CICS is the engine that processes the transaction that access that data. Now let's talk about our next component, that is DB2. So IBM Relational Database or DB2 runs on ZOS operating system and is one of the most important part of the entire mainframe ecosystem. The majority of mainframe applications store their data in DB2. So DB2 on ZOS is especially optimized for this environment, deeply integrated into CICS, RACF, and the rest of the stack, and it scales to transaction volume that would be impossible on standard database system. Now let's address the comparison that always comes up. How does ZOS compare to Linux and Windows? And the honest answer is that it depends entirely on what you need to do. These are not the competing products in the way people often suggest. They are designed for fundamentally different workload. And we're going to do a comparison based on four different what you call attributes or the areas. First one is reliability, second one is scalability, then security, and of course the cost. So first one is reliability. So a well-known Windows environment might achieve 99.9% availability, roughly 8 hours of downtime per year. On the other hand, if you talk about Linux, is a well-run enterprise setup and it can reach up to 99.99%. That is about 50 minutes downtime per year. Now, if you talk about ZOS, which is designed for 99.999%, which is less than 5 minutes per year, and many production installation exceeds that, running for years without a single unplanned outage. Now let's talk about our next parameter, that is scalability. So Linux actually scale horizontally. You can add more servers to handle more load. This is how cloud platform works and it is extremely flexible. But it also means managing hundreds or thousands of servers, dealing with network latency between them, and handling the complexity of distributed systems. On the other hand, when you have ZOS, it scales vertically and very effectively. One machine, one operating system, more workload, add more processor or memory to the same box. No distribution complexity, no network latency between component, everything is local. So that's a big difference. Now the next parameter is security. So all three operating systems have strong security features. But ZOS has a significant advantage in regulating environments. RACF provides centralized, auditable, and fine-grained access control that has been tested and trusted by various organizations for decades. Now, the next important parameter is cost. This is where the conversation gets nuanced. Mainframe hardware is expensive, ZOS license is expensive, but when you factor in the total picture, that is hardware, software, staffing, downtime, and risk, many organizations find that consolidating on ZOS is actually cheaper than running hundreds of Linux servers doing the same work. The bottom line here is that ZOS is not trying to compete with Linux for web application or developer tooling. And Linux is not trying to process 1 million banking transactions per second on a single machine. They are different tools for different jobs, and the world need both. Now let's talk about ZOS and the cloud. And one of the most common question about ZOS is whether the cloud will eventually replace it. And the short answer is not anytime soon. And increasingly, this question itself is changing. It's no longer about cloud or mainframe, it's mainframe and cloud. So IBM has invested heavily in making ZOS a cloud connected platform. Modern ZOS environments run Linux containers alongside mainframe workload on the same hardware. They expose mainframe data and services through REST APIs that any cloud application can consume. They integrate with hybrid cloud platforms like IBM Cloud and Red Hat OpenShift. The pattern emerging in large enterprise is this: keep the core transaction processing, the high volume mission critical systems on ZOS where it has always run, and use the cloud for everything around it: analytics, customer facing application, AI workload, and development environment. The mainframe become the reliable core of hybrid architecture, not a legacy system waiting to be replaced. A trusted engine at the center of a modern technology stack. And this is the direction the industry is moving, and ZOS is evolving to meet it. Now let's talk about something practical, that is careers. The mainframe skill shortage is real and it is getting worse. The generation of engineers who build and maintain these systems is retiring. The number of graduates who are entering this field is small, and the demand for ZOS expertise is not going away because the system themselves are not going away. What does this mean for you? It means ZOS skills are genuinely rare and they are genuinely valuable. Roles like ZOS system programmer, KICS developer, DB2 DBA, JCL developer, or mainframe security analyst command the salaries that are constantly higher than equivalent role in mainstream technologies. And the competition for those roles is significantly lower. If you are a developer looking for a differentiator, a skill that sets you apart in a market full of JavaScript and Python engineers. So learning ZOS is one of the smartest move you can make. And we have also published a couple of courses on JCL, COBOL, Rex programming. And in case if you want to learn that, then you can find the link in the description. It is the fastest way to build these skills right from the scratch. So what is ZOS? It is an operating system that quietly runs the world. It processes more transactions every day than any other system on planet. It achieves reliability with no other platform has matched. It has been evolved continuously for over 50 years and it is not going anywhere. If you work in enterprise technology or you want to, then understanding ZOS is not optional, it is foundational. I hope this video gave you a clear picture of what it is, how it works, and why it matters. If you find this video helpful, then please consider subscribing to our channel and do hit the like button. We publish new mainframe and enterprise tech content every week, and we have also provided the link to our Udemy courses. So do check out our YouTube channel, our website, and our courses on Udemy. So once again, thank you so much for watching the video.